Okay, so we're going to have a look at this question here. This question is a question 1 FRQ, so functions concepts. And let's have a little look at the question. So we're given a table of values and we're asked to find, we're told that in the table of values it shows selected values of the increasing function f on its real domain. The function g is given here as a rational function. And our first task is for the function h is defined as h of x is equal to g of f of x. Let me see, how am I going to do this today? And h of 1 as a decimal. We want h of 1 as a decimal approximation. So I'm just going to write here a little bit for this assignment today. So we need to find h of 1. So that means we need g of f of 1. So firstly, we will find f of 1. We look in the table here. When we enter 1 into f, we get 12. So our first is 12 here. We now need to put in 12 into the function g. So I'm just going to pop. Ooh, do I still have my thing up there? Yes, excellent. Okay, I'm just going to get my calculator. I'm going to do quite a bit in this assignment with the function g. So it's probably best to define it. So I'll press Control, Add Page. I'm going to add a graph. Press Control Divide, and I can type the function in. If you want, follow me along at home on your calculators. Practice typing it in, practice the routines. So we get this. So the first thing I want to do is I want to evaluate what the function is when g is equal to, when g is entered with 12. So we'll just pull up the function there, press Enter. Check my decimal, how many decimals I'm giving at the moment. So just go to my document settings, put it into fix 3. The AP tends to like 3 decimal places in the decimal expansions. Press Enter again, and we get our value. So our answer here on this one is equal to 1.5625. Okay, next question. So our next question asks here that we find all the real zeros for g and indicate any non-real zeros. Sorry, indicate there are no real zeros. Best way to solve this question is to graph it and look at the graph. So if we look at the graph of the function, we can see the shape here. We're heading off to an asymptote there and there. So the function is only actually crossing here at this one point there. The purpose of looking at the graph for this type of function, instead of just putting it into nsolve, is in case you don't understand the shape of the graph and there might be more than one. If you just nsolve something, you will get one answer. If there are multiple answers, you want to make sure that you can see how many answers there are. So we're looking for the zeros of this one. We will press Menu, Analyze Graph, and find the zeros. Left bound is below where it happens, right bound is the other side, and we can see our answer there. We've got -0.5 as our answer. So we want to find g of x is equal to 0. Sorry, let me nerd it up a little bit. There we go. Select, copy. Implies that x is equal to -0.5. Oh, what happened there? It didn't like. Okay, I'm going to have to use this, I think. All right. Find all values of x as decimal approximations for which g of x is equal to -4.7 or indicate there are no such values. So again, your best technique here for this one is to visually look at the graph. We want to see where it comes to minus 4.7. So there's only going to be one solution to this one. I'll show you two techniques for this. We'll press menu. No, we won't. Escape. We'll start by pressing tab. I'd recommend putting in minus 4.7 as a function. Y equals minus 4.7. Oops, did I do that wrong? Yes. Y equals minus 4.7. That looks more like it. And then just finding the intersection of the two graphs. So we find the intersection between here and here. We get our answer there. So we can motivate this up as g of x is equal to minus 4.7. Implies that x is equal to, lowercase x is equal to, what did I get? 2.955 minus 2.955 ... I'll show that this is rounded there. It's a little bit better. Notation, let me check that. That needs to be lowercase. Okay, another technique that you might use to do this, we can see that there's one solution. So if you know there's one solution, then you can use nsolve. If you don't, you want to be a little bit more careful for it. So just nsolving this one, I can use the function 1 of x is equal to minus 4.7, solve for the variable x, and it will give me the answer there. Okay, determine the end behavior. Dear me. Express this using mathematical limit notation. So the important thing on this one is to read the question carefully. So we have, what type of pens do I have? Do I have a highlighter pen? So the important thing on this one is as x decreases without bound. So this means we need the limit as x is going backwards. I'm going to try and do it with my little text editor here. It's really important that you format this correctly. So this is going to require that I draw it by hand. I can't. So we need x goes towards in. Where's my iPad when I need it? Right, let me start this again. All right, we want the limit as x goes towards infinity. No, we don't. We're going towards negative infinity. It's really important that your x arrow infinity is under the limit function. The format of this needs to be very clear. G of x is equal to, now let's actually try and answer the question and look at the calculator. So if we look at the graph, as we go towards negative infinity, we're going to some value up here. To get that value, take your function and then enter in a large negative number. Well, that value is going towards 2. You can see here that the value is approximately 2. The larger I make that number, the closer it will start getting rounding errors and it will actually give it as 2, although it never gets there. We can see this as the limit value. It's very easy to find this type of limit value. So the value that we're going to get is, it was not 4, it was 2, wasn't it? It was 2. Okay, let me just pause the video for a second. Okay, so sorry about my use of my pen here. Find the function g of x, which is the inverse g to the... Find the function g inverse, the inverse of g. Right, I'm going to switch to my iPad here on this one. Overlay this over the top. So we have the function, and we're going to just start off by switching x and y. and we get this 2y plus 1 all over y plus 4. I'm going to multiply both sides by this bracket, and I get the y plus 4 comes up here, is equal to 2y plus 1. And then I'm going to expand the bracket on the right-hand side. xy plus 4x equals 2y plus 1. Factor the left-hand side, move the 2y across and factor. So we're going to get y bracket x minus 2. And then move the 4x over this direction. And by pulling it down and giving it as an inverse function, so we get g inverse of x is going to equal 1 minus 4x all over x minus 2. Now, on this function, we would have to say that x is not equal to 2. This is the domain of the function.
What if we didn't write x is not equal?
You risk not getting the point.
But it didn't ask for it.
That's why the domain. Word.
You want to give a correctly defined function. Right? Determine if f is exponential, logarithmic, and give your reasons for stating this. So if we look at the function, we can see that as x increases in a linear pattern, y decreases by a factor of a half, if you look at the function. So this means it is exponential. So in part 2, we're going to say exponential as input values increase by +1, the output values decrease proportionally by a factor of 1/2. So a nice clear definition there on that one. Okay, that is it for question 1. Yes. Sorry, let me.